This channel does not promote or encourage any illegal activities. All contents provided by this channel is meant for educational purpose only.
Hey everyone, today I'm showing you how modern Infostealers actually work in the real world. This is a quick demo of my private crypter with a really well-known Infostealer called ChromeElevator that attacks the Chromium. And for make it easier to me to present this demo, I just made a few slides. To me it's much easier. Well, the attack chain is really simple in this case of the demo. I just like the laptop, imagine a laptop is unlocked and you just use a flipper zero or a dark script. In this demo, I asked my mom if I can just try my malware. In this case, I use my custom C2, my custom command and control code with Rust. It's still private, but the idea is make it like open source. Okay, so let's dive in. As I say, the first idea is the laptop. It's an analog laptop. That's like the initial access. The step 2 is like the custom loader gets dropped and gets like user execution. It could be Havoc C2, Metasploit, whatever. Doesn't matter really in this case. Oh, these numbers are the tactical procedures and techniques of the Mitre standard. The step 3, it is about the antivirus stays quiet, like the code runs. It gets evasion with obfuscation and using like a technique called living of the land. Well, after that, the step 4 it is attack the Chrome and Edge. For every Chromium-based browser credential access, and with that we get the step 5, that is getting the cookies, tokens, fingerprints, everything exfiltrated. With no alerts, no pop-ups, no user interaction, and we can use this information to recreate with another browser the real sessions of the browser. And many APTs or attackers use SOC 5, SOC 4, or just VPNs to like assimilate the IP of the real person. Or in some cases, when they use as a botnet, they can just like pivot them or just like literally suck and proxy the browser over the victim and having access to it. That's like really complex, and today we are not gonna talk about that. Maybe another day. So, what's going to damage, right? What's actually the damage? Basically, just things Windows already trusts. It trusts a custom loader encrypted with a crypter, a private crypter, or an unknown crypter for the antivirus solution, Microsoft antivirus solution. I didn't test with another enterprise solution, EDRs, XDRs, or just Kaspersky. I don't know. ESET, Bitdefender. Just tried with regular antivirus, like the Windows Defender that almost everyone has on their computers. So a custom loader with a crypter, and well, it has the Infostealer, and it uses native Windows binaries for exfiltration. This is what we call living of the land, or LOLBins. and we exfiltrated just encrypted on the C2 over the C2. Yeah. About the crypter, this isn't about bypassing the V1s, right? Because it's about running where you shouldn't, hiding inside trusted processes, and never touching disk twice. You guys have to remember that browsers are like high value targets, are like an important attack surface for cyber criminals, because it has like many information, critical information of a person. So what came out inside the browser, right? We have like the app-bound encryption key of Chrome, and Brave use the same. We have cookies, tokens, browser fingerprints, and profile artifacts. Well, active session cookies, well, the key, browser fingerprint, well, etc. A lot of information, and we exfiltrated via tar with the tar.exe. We like tar the file. We zip the folder, and we exfiltrated via C2 tooling, like try crafting, featuring. And the important thing of LOLBins or LOLBins or living off land is that they are assigned binaries, and the behavior or how you use these binaries in general is like well except for the major antiviruses. Of course, of course in this case I just use Microsoft Windows Defender, and more or less it works a little bit worse than most of antivirus or enterprise EDR solutions. And it's more or less the same, right? For example, for executing a binary, you can use another binary, another exe file. If we go to the LOLBins website, we can see that if we just scroll a little bit, we can use change.exe to execute an exe. Sorry, exe. No, what? And it has the attack technique of the MITRE framework. But for example, we can use bash.exe. We can use at.exe for execute, and it explains how to use it, right? This is like a very common website to attack Windows Enterprise networks. In this case, it works for like a single workgroup of a machine, or just a computer, right, with Windows 11, Windows 10, etc. And here we can see the attack technique, the MITRE technique, right? This is like a scheduled task job, right? For example, the system will lie, the path of the exe, when, how, every month, Monday, Tuesday, blah blah blah, and the program per se, right? Okay, but now what defenders would see? In this case, when I'm talking about defender, I'm just talking about the antivirus, not a SOC, not a CM, nothing too fancy, okay? Because we have just these things. You guys will see on the demo that there exists a checker.exe and a set.exe. One of them is the agent of the rat, of the Roman of the rat remote access tool, sorry. And the other one is just the Infostealer, that in this case is not 100% fileless, just in part. Okay, And the output archive, yes, the output archive goes over file system. This of course could be match and doors, but for the sake of this demonstration it wasn't necessary. Just the antivirus that doesn't care, that doesn't trigger anything. And more or less the telemetry that appears is the suspend for every Chromium based browser process and remote threads via syscalls. This is a little bit suspicious if you're against any VR and the IPC pipes. That with this you get the keys, right? And the advanced C2 traffic too, but not that much, because in many cases the C2 traffic goes over trust services. For example, AWS content delivery network and other things. There exists a real good page that it calls, instead of LOLBins, it calls LOLC2, that explains how command and control can abuse legitimate servers to evade good detection, right? In this case, I don't use any of this. I just use a regular C2 encrypted over an SSH server. Okay, but how could have been stopped? Like, why this happened? Why so many people got pwned? First thing to keep in my mind is download random shit from the internet. Don't download pirate software that you don't trust. Don't download that crack. Don't download free hacks. Don't download more RAM or those kind of things. You know, don't download shit from the internet. That's like an important rule. Or if you're downloading shit, random shit from the internet, you have to be more or less know what you're doing, what you're downloading, and of course knowing the risk. And now, in this example, I just paste a screenshot of the final work. That's on my C2 server, in this case, just my Raspberry Pi. We can cut a password JSON and grab my email, and of course it dumped with the passwords. And these are old websites that were stored on my really old mom's computer. So of course you can just Google this on how I've been banned, and you will see those passwords that are all of course rotate a long time ago. But the important thing is, like, browsers are literally a really important attack surface. They are like a critical software, and literally the most infections are user decisions, not 0 days, just bad choices. Don't literally. Well, now we will see the demo, right? Well, we have compromised my mom's computer in this side of the monitor, and in the other side I'm gonna send her a famous Infostealer that is called ChromeElevator. Yeah, it is ChromeElevator. Let me go a minute. This one we have. This one is not loading. Oops. No server error. Anyways, it's a well-known, famous malware. So, wow, this one is a well-famous, like, Infostealer simulator, but I'm going to use it in an intended way of stealing information, trying to bypass the antivirus, and for that I will use a crypter that has their own stub. Oh, what happened? Well, there are like 2 agents connected to my mom's computer. And by the way, I have permission from my mom to doing this. So this was here, I guess, on repos. C2 deeper crypter. I call it like that. I think it's the how it encrypt. I think it's this one. Like for example, if I execute this on my computer, yes, it is. It is. So, for example, I'm gonna use it on my own computer. Entirely, like, I'm gonna try to dump all my credentials. For example, I want to, I don't know, for example, the ads with the propose, with the fingerprint, and I want to dump it here, right? And it worked. Okay, so where is this? This path. This is my own C2 server with an API, and I'm going to use the upload method. If we upload this file to the remote, yeah, here it's okay, I guess. And we call it checker. I don't know, checker.exe. Oh, never mind. Never mind, it worked. Okay, maybe it's like too slow, the process, but it is working. Like, I just like, my mom just like went to the barber or like to the I don't know how to say in English. In English, like when women go to cut, have a haircut. Like a women hair salon, yeah. And I just like log in her computer and just put the binary, and I'm trying to like simulate a compromised chain, right? It says that it was execute, and we have the outbound encryption key. We have the edge. This is the dash help. Yeah. Okay, the first command was this one, right? I mean, response. Yep. But it's not like something like very specific or private, so I can. But I have the fingerprint of Chrome. Here we have the fingerprint of the edge. So we like this is like a chain compromise of letting like a laptop unlock some random dude like me, hypothetically talking, infects your computer with a malware, in this case a rat, and it has his crypter, his own crypter, and the crypter encrypts the a famous, well-known GitHub like open source malware. This one. GitHub is not working well today. With a crypter, it is possible to send it to a victim machine, like execute it, and have results without triggering the antivirus.